Nearly every type of machine experiences a certain amount of vibration. Sometimes vibration occurs as a normal part of a machine's operation, but at other times, vibration is an indication of a problem. Since vibration is capable of causing damage to machines and their components, it should be monitored. Some machines are equipped with built-in vibration monitoring devices. For other machines, you may be responsible for measuring vibration levels and either analyzing the data or providing it to other personnel for analysis. To do your job correctly, you need to understand what vibration is and how it can be measured. To see what happens when an object vibrates, we'll use this illustration of a block suspended by a spring. When the block is pushed down and released, it reverses direction and moves upward, reverses direction again and moves downward, and so on. Like the block on the spring in our example, rotating equipment reacts in a similar fashion to an external force. However, it's worth noting that the amount of movement in rotating equipment can be much smaller, and the rate of vibration is usually a lot faster. When this block travels from a starting point between two extreme positions and back to the starting point, it has completed one cycle. When an object vibrates, the velocity of the vibration changes constantly. When this block moves past the center position, it's traveling faster than it is when it reaches one of the extreme positions. Because the velocity of a vibrating object is constantly changing, the highest velocity measurement is generally used or displayed. This velocity is known as the peak velocity. A vibrating object's acceleration is constantly changing, so the peak acceleration is what's used or displayed. Any piece of equipment that includes rotating components vibrates. In general, vibration causes machinery to move in all directions rather than in just a single motion, and the amount of movement or displacement is usually quite low. For example, when this impeller is struck, it will vibrate at a specific frequency that is its natural frequency. Equipment that includes a number of rotating components may have more than one critical speed. For example, this shaft assembly has several critical speeds. It could be dangerous to operate this shaft assembly at any of its critical speeds. However, the operating speed of some machinery cannot be controlled. In these cases, the machinery is normally designed to operate at speeds other than the critical speeds of its components. On machinery for which the operating speed can be controlled, how do you suppose safe operating speeds are normally determined? Safe operating speeds are normally specified by the manufacturer. In addition, operators are usually taught to avoid operating rotating equipment near any of its critical speeds. Besides the effects of operating equipment at critical speeds, excessive vibration in rotating equipment is generally caused by problems with rotating components. When a component doesn't rotate properly because of damage or some other problem, abnormal forces are generated, and they occur repeatedly. These forces cause the component to vibrate. When this vibration is analyzed with vibration monitoring equipment, its cause can usually be identified. One of the most common causes of vibration in rotating equipment is an imbalanced part. A rotating part becomes imbalanced when its weight is not properly centered on the axis on which it rotates. A rotating part could be imbalanced because of a manufacturing error, wear, or physical damage. Another common cause of vibration in rotating equipment is shaft misalignment. Even a small amount of misalignment between shafts can put additional stresses on the shafts and their bearings. These additional stresses produce their own distinct vibration. Vibration can also be caused by a shaft that is bent or out of round. The effect of a bent shaft is similar to that of a misaligned shaft. When a transducer is used to take vibration measurements, it's either held in position by hand or it's mounted to the equipment. Proper placement of a transducer includes how it is held or mounted to the machine it is monitoring, as well as where the transducer is positioned. For example, The surface a transducer contacts should always be smooth and free of any material that could interfere with the contact between the transducer and the machine. Many transducer manufacturers recommend using a silicone grease between the transducer and the machine that's being checked. The grease helps fill any gaps between the transducer and the surface of the machine to ensure that there is a large area of contact. It also prevents the transducer from chattering on the surface of the machine. Many transducer manufacturers recommend using a silicone grease between the transducer and the machine that's being checked. The grease helps fill any gaps between the transducer and the surface of the machine to ensure that there is a large area of contact. It also prevents the transducer from chattering on the surface of the machine. Transducers can be placed on a machine in a number of ways. The method used in a particular application may depend on the type of machine that is being checked. If a machine that is being checked for vibration has more than one set of bearings, each bearing should be checked if possible. Also, if possible, each bearing should be checked from 3 different directions. That's the minimum number of directions needed to completely check the vibration. For example, the bearings on this vertical shaft should be checked from an axial direction, that is, parallel to the center line of the shaft. From a radial direction, that is, perpendicular to the center line, and from a second radial direction, that is at a 90-degree angle to the first radial measurement. On a machine with a horizontal shaft, the bearings would also be checked from an axial direction and from 2 radial directions. Typically, one radial measurement is taken horizontally and the other is taken vertically. It's a good practice to mark the points where a transducer is placed on each bearing so that the same positions will be used on subsequent readings. If different positions are used each time the machine is checked, the vibration readings may be accurate, but they will not be useful for making comparisons with past or future readings on that machine. The purpose of a vibration meter is to provide a general reading of a vibration's overall level. Vibration meters are useful because they are small, lightweight instruments that can be easily taken from one test point to another. Whenever a vibration meter is used, there are some basic guidelines that should be followed to ensure that the readings are accurate. It's important to follow the manufacturer's recommendations and specific company procedures for using the meter. Also, before the meter is used, the transducer, the cable, and the meter should be visually inspected for signs of damage. In addition, if a vibration meter is due for calibration, it should be calibrated before it is used. If a vibration meter is powered by a battery, the battery should be checked before any readings are taken. If the battery is in good condition, the indication will be within the range of the battery voltage level scale. If the battery is weak, the indication will be below the low end of the scale. Any readings you take with a meter that has a weak battery may not be accurate. If a vibration meter is powered by a battery, the battery should be checked before any readings are taken. If the battery is in good condition, the indication will be within the range of the battery voltage level scale. If the battery is weak, the indication will be below the low end of the scale. Any readings you take with a meter that has a weak battery may not be accurate. To take a vibration measurement, you need to properly place the transducer on the component to be monitored. The next step is to use the function switch to select the vibration characteristic that is to be checked. If you're going to be taking overall vibration readings, it's usually best to start by selecting velocity, because it's a good general indicator of the severity of the vibration. After you set the function switch, you need to set the range switch. If you're not sure which range setting to use, it's good practice to start with the highest range and work downward when you begin taking readings. Once the switches are set, the meter is turned on. Taking a vibration reading is not difficult, although it does involve several steps. Generally speaking, if the vibration indication is in the low end of the scale and difficult to read, then the range switch is moved to a lower range to get a better indication. Assume that you need to take some overall vibration readings on a piece of equipment. Vibration analyzers are generally used to examine individual vibration frequencies and provide detailed information that can be analyzed to help identify a specific problem. In this part, we'll begin by talking about how to use a typical portable vibration analyzer, and then we'll talk about how to use a typical computer-based vibration analyzer. During operation, the strobe light is pointed at a moving object, and the speed of the strobe is adjusted. As the speed of the strobe begins to match the speed of the object will appear to slow down or stop. All vibration analyzers have specific instructions that should be followed to ensure that the collected data is accurate. For example, before this unit is used, it should be checked to make sure that it is in good condition. If the unit runs on battery power, the batteries should be checked to make sure that they are sufficiently charged. After the analyzer has been checked out, the 3 control switches are positioned. The settings for these switches are determined by the task to be performed. In general, the highest range for the amplitude meter is selected to begin a measurement. If the amplitude indication is too low to read accurately, the next lower range can be selected. The next step is to select the vibration characteristic to be monitored. Velocity is generally checked first, since it provides useful information about vibration over a wide range of frequencies. However, the actual choice may be based on the company's vibration monitoring program or on the speed of the machine being tested. After the vibration characteristic has been chosen, the frequency filter switch setting is selected. Usually, a vibration measurement is begun by taking an overall reading. After all of the vibration analyzer's control settings have been made, the transducer is positioned at the proper location and the data is collected. The amplitude meter indicates the amplitude of the vibration characteristic that's being measured. The frequency meter indicates the frequency that has the greatest amount of vibration. If specific frequencies are to be examined, the frequency with the greatest amount of vibration is a good first choice. To choose a specific frequency, you need to select a narrower frequency bandwidth that includes the desired frequency. The data collection process can continue until all of the desired readings have been taken. This analyzer has a printer function that can be selected to obtain a printed chart of the readings. The chart can be used to identify frequencies that have a high level of vibration. This information is helpful in tracking down faults. The chart can also be compared with charts of other readings taken over a period of time from the same machine. Before a computer-based vibration analyzer is used, the batteries that power the data collector should be checked. Information about the machines that are to be monitored is transferred to the data collector from the computer. This information may include the types of machines being monitored, the locations of the machines, and the specific points on the machines where the transducer will be attached. The data collector is then disconnected from the computer and taken to the first machine from which data will be collected. Usually, an overall reading of vibration velocity is taken first. An overall reading of vibration velocity is generally taken first to determine the general mechanical operating condition of the machine being tested. Specific frequencies and different vibration characteristics can then be measured if required. After all of the information has been collected, the data collector is reconnected to the computer and the vibration characteristic values are transferred from the data collector to the computer. The computer can then perform the vibration analysis. This analysis includes a display of the data as a graph on its screen. It can also store the data and the results of the analysis in its memory for later review. Often, readings collected over a period of time from the same machine can be compared to each other to see if a problem is developing. Why is silicone grease often used between a transducer and the machine being checked? The main purpose of analyzing vibration is to diagnose the condition of a machine so that the problem that's causing unwanted vibration can be identified and corrected. Vibration analysis is also used to verify that equipment is operating within acceptable vibration limits and to detect developing problems in equipment. Analyzing vibration data usually involves making a detailed examination of vibration characteristics. The information that's obtained can be used in different ways. The amplitude of a vibration is measured to determine the severity of the vibration. The greater an amplitude, the more severe the vibration. Analyzing vibration data usually involves making a detailed examination of vibration characteristics. The information that's obtained can be used in different ways. The amplitude of a vibration is measured to determine the severity of the vibration. The greater an amplitude, the more severe the vibration. One way to examine vibration is to look at the amplitude of a vibration over essentially the entire frequency band. One way to examine vibration is to look at the amplitude of a vibration over essentially the entire frequency band. If a machine's overall level of any of a vibration's characteristics stays relatively constant at an acceptable level over the course of several routine measurements, then the machine is probably in good condition. However, even small changes in a machine's condition can produce large changes in the amplitudes of its vibration characteristics. A machine that has a developing problem invariably shows an increase in the amplitude of one or more vibration characteristics. An important part of analyzing vibration data is comparing it to information known as baseline data. The term baseline data is used to describe information that is collected to use for comparisons with future readings. By making comparisons to baseline data, personnel can determine whether a trend exists. A trend away from the baseline data can indicate that a problem exists or that a condition is changing. This information can help maintenance personnel reduce unnecessary equipment downtime and schedule shutdowns to repair the equipment. Baseline data that is taken before repairs are made can be compared with subsequent readings to determine if the problem has been corrected and to check the quality of the repair work. Data that is taken after the repairs have been made can serve as new baseline data for future readings and comparisons. Now's a good time to check your understanding of the basic concepts of analyzing vibration. Now's a good time to check your understanding of the basic concepts of analyzing vibration. Vibration data may be analyzed by the person who collected it, or it may be given to other personnel for analysis. In this part, we're going to look at vibration signatures and the charts that are commonly used to show them. A vibration signature is a representation of the amplitude of a vibration over a range of frequencies.